Assalamualaikum warahmatullahi wabarakatuh. My name is Beti Agustina Asih, and now I will explain you how to prove injective, surjective, and bijective using graph and algebra.
First, I will prove a function with a graph. I using GeoGebra for see the graph of the function. Okay, the first function is fx equal to 2x plus 3, and the graph of function is like this, that intersection in one point in y and one point in x. To prove this function is injective or not, we must check with horizontal line. So take y equal to 6. So this line intersects with the graph of function in one point. Okay, if we take another line, for example, for y equal to -3, same with y equal to 6. This is intersection in 1.2 with the function. So we know that this line is injective because for every horizontal line, there's intersection in one point in the function in the graph of function. Next, to prove this function is surjective or not, we must know that for all of the real number have one value, we know that this function have infinite line, so this function is surjective. Okay, the second function is we have that fx equal to 2x squared plus 3, and the graph of function is like this, like u. So to prove that this function is injective or not, same like the first function, we must to check with horizontal line. So take y equal to 7. So the line is intersect with the graph of function in 2 points. Okay, we must to check with another line. We take y equal to 5. Same with the y equal to 7. The line is intersect in up 2 points with the graph of function. So because line is intersect with the graphic of a function in a 2 points, so this is not injective function. To check this is the surjective function or not, take y equal to 2. There is no value for y equal to 2, so there exists the real number that not have value the function, so this is not surjective function too. But if we have y equal to 3, the function will intersection in the one point with the line of y equal to 3. So if we have y equal to 3 and the domain is y bigger than or equal to 3, so this function will be the surjective function. Okay, next I will prove the function with algebra. From the first given f from real number to a real number with fx equal to 2x plus 3. For proof this function injective, surjective, or bijective, first take any x1 and x2 element of df, the domain of fx, where x1 not equal to x2. So x1 not equal to x2 implies that 2x1 plus 3 not equal to 2x2 plus 3. So we get fx1 is not equal to fx2. Because fx1 is not equal to fx2, so fx equal to 2x plus 3 is injective. This is fulfills the injective that for every x1 is not equal to x2, so fx1 is not equal to fx2. For proof this function is surjective or not, So take any y element of real number. Choose x equal to y minus 3 over 2. So fx equal to 2 times y minus 3 over 2 plus 3. We can cross out the 2 with 2, so fx equal to y minus 3 plus 3. So we get fx equal to y. Because fx equal to y, so fx equal to 2x plus 3 is surjective. This is fulfills the surjective that for every y element of real number, so fx equal to y. Because fx equal to 2x plus 3 is injective and surjective, so fx equal to 2x plus 3 is bijective. Because for every function will be a bijective function if and only if the function is injective and surjective. Next problem is given gx from real number to a real number with gx equal to 2x squared plus 3. Similar with problem 1, take any x1 and x2 element of dg or the domain of gx where x1 is not equal to x2. Choose x1 is equal to 1 and x2 equal to negative 1. For x1 equal to 1 implies that 2 times 1 square plus 3 is equal to 2 plus 3 is equal to 5, and for x2 equal to negative 1 implies that 2 negative 1 square plus 3 is equal to 5. Because both of them have the same values, so gx1 is equal to gx2. It means that gx equal to 2x squared plus 3 is not injective because there is same values for different x1 and x2. Next, for the proof that this is surjective or not, so take any y element of real number. We can choose x equal to the square root of y minus 3 over 2. So gx equal to 2 times the square root of y minus 3 over 2 squared plus 3. Gx equal to 2 times y minus 3 over 2 plus 3. Gx equal to y minus 3 plus 3, so we get gx equal to y. But if we choose x equal to the square root of y minus 3 over 2, so y minus 3 over 2 must be greater than equal to 0. So y minus 3 greater than equal to 0, so we get y greater than equal to 3. It means that not all of the real number is the range. So gx equal to 2x squared plus 3 is not surjective. Because we get y greater than equal to 3, so there exists codomain, then no range. But if we change the codomain to range equal to y greater than equal to 3, so the gx equal to 2x squared plus 3 is surjective function. Because from the up, we get gx equal to y. So with the range of y greater than equal to 3, gx is surjective function. But for the range is real number, this is not surjective function.